ARIS Explorer sonars create video-like images underwater, even in low light, deep water, and turbid conditions, making them essential tools for fish surveys and behavioral studies in remote river systems. The sonar works by projecting a fan-shaped acoustic beam through the water, much like a flashlight. It operates in two frequency modes: a high-resolution 1.8 MHz identification mode with a 15-meter beam, and a lower-resolution 1.1 MHz detection mode that extends to 35 meters. For the North River project, the sonar was set to 1.8 MHz to generate accurate fish length, speed, and count data. Because the beam is made up of 29 rays, fish need to pass perpendicularly through it. This orientation improves data quality and minimizes the acoustic shadows created by fish or other large objects. Each ARIS kit arrives with cases, tools, and manuals, along with several motorized rotator arms that can be configured for different deployments. For the North River setup, a single rotator arm, baseplate, and bracket were used. This combination allowed the sonar to be rolled side to side and tilted up or down at the bracket, arm, and arm base connections. For the North River setup, the baseplate fastened to the sonar created the pivot point to roll the sonar side to side. Attaching the bracket to the rotator arm created the pivot point to tilt the sonar up and down. ARIS kits do not include a stand, so one must be built from corrosion-resistant materials. On the North River, the stand consisted of a column and arm and a milk crate mounted to a baseplate to hold the anchoring weights. The arm's height and tilt were adjustable and provided the mounting point for the ARIS bracket. Power and data run through the 150-meter main cable, which connects to the rotator arm and then a short secondary cable to the sonar. At the connection points, lubricant is used to ensure a watertight seal, and a metal wedge sets the required spacing between the connectors. A weather box was placed near the power outlet supplied by the landowners. Patio stones were added inside to secure it, and the box was modified so cables could pass through without leaving the lid open. Inside, backup systems and support gear were organized, including a generator, the ARIS power data cable spool, a Starlink router for remote desktop access, and a laptop with an external drive. The ARIS command module links the sonar to the laptop through the 150-meter cable and displays system status. ARIScope software provides control panels for scheduling recordings, managing data storage, and adjusting the roll and tilt functions of the rotator arm. Once the beam is positioned, placing an object of known size in the water helps verify length measurements at different distances from the sonar. This setup allows the ARIS Explorer to operate reliably in remote river conditions, capturing clear, measurable images of fish as they move through the beam. With the stand secured, the system grounded, and ARIScope managing the recording, the sonar can deliver consistent, long-term data streams for assessing salmon migration.